Hello guys, today I'm going to explain you how can we solve this problem from Leetcode's weekly challenge. And this problem statement says that given an array bloom day, an integer m and an integer k, what we need to do is we need to make m bouquet, and to make a bouquet we need to find we need to use k adjacent flowers from the garden. Right, so the garden consists of n flowers. So this bloom day is the garden array, and the ith flower will bloom in the bloom day I. So, and we can use exactly one flower for one bouquet. So once it is used, we will not be able to use it to make another bouquet. So what we need to do is to return the minimum number of days that we have to wait to make all the m bouquet if it is possible, and if it is not possible to make a bouquet, we need to return -1. Let's try to understand this example. So here we are given this bloom day array, which is also our garden array, and m equals to 3. That means we need to make 3 bouquet, and we need to use exactly one adjacent flower for making each bouquet. So here a very nice explanation is given that how this garden will look like on day 1 and day 2 and day 3. So on day 1 only one flower will bloom, so, and that is the first one, so we can use it because we can use at we need to use at exactly one flower, one adjacent flower to make one bouquet, so we can directly use it. Similarly on day 2 we can see this last one also bloomed, so we can use this one as well. And then that on day 3, so we can wait for only 3 days to make all the bouquet.
So let's try to see this example, and then we'll try to also understand how our approach works. So in this given array, we'll need to make 4 bouquet using 2 adjacent flowers for each bouquet. So one key observation that we can make here is, regardless of this metrics that are given to us, if there exists an answer, that answer will lie between the minimum value of this array to the maximum value. Alright, because as we can observe here, the first day any flower blooms will be the minimum value of this array. So for example, here it is 1, and the last day which any of the flower blooms will be the maximum of this value. So we cannot make a flower before this one and after this one, so we cannot have any other flower before this min or after this max. So whatever the answer, if it is possible, would be within this range from 1 to 10. Now let's talk about the possibility, the part that we were saying. Whenever it is possible to make this number of bouquet, this given number of bouquet, the answer would always lie in this one. So let's first talk about the case when it is not possible. So it is only not possible when the number of the flowers in this array are less than the amount of flowers that we need. So for example, here we will need total 8 flowers because we'll need 2 flowers to make each bouquet, and so total will be 8. And here the size of the array is, as you can see, it is 10. So we can wait at till the last day, the last day when a flower will bloom, and in that case all of them will be bloomed already. So we can pick any we can pick any 2 non-overlapping subarray, and we can simply make this bouquet. So yeah, that will take, regardless of the efficient approach, we can just pick any one. Now this is obvious that if this array size is bigger than or equals to this number of flowers that we need, we can always make. And so if it is possible to make all these m bouquet, the answer will always lie between the minimum and maximum value of this array, as we discussed. So now let's try to find out how efficiently we can find our minimum answer. To understand our best approach, let's first try to take a closer look onto the nature of this problem. So if we say that, let's say on some day ith, this became possible for the first time to make all the bouquet. If we take a look here, so what happens here, if it is possible to make all the bouquet on this day, it will always be possible to make all the bouquet on this day as well as on this day, on this day, on this day. So basically, if this become possible to make a bouquet on some particular ith day, then we will always be able to make all the bouquet for the further days. If we ask that will it be possible to make all the required bouquet in 8 days, the answer would be yes. And similarly for 7 and 9 and for 10. I'm just taking a hypothetical example here, not considering the actual answer for this one. But if we ask same question, that if it is possible to make all these bouquet before this ith day, the answer is no. So we can just simply say that all the answers below this one, for all the days after this, it is possible to make, and for all the days before this day, it is not possible to make this one. So now we need to just find the first day. So this will, as you can also understand, that now the answer for our problem would be this particular day, the day at which it first became possible to make all this bouquet. So now let's try to think how can we find this ith day. So one simple approach, and which is naive approach as well, we can try to do a linear search from minimum day till the end, and first time whenever we see that this was possible to make all these m bouquet, we can simply return that particular day. But linear can time out because we'll have to traverse from 1 to 10, and min and max can be 1, and maximum can be 10 raised to the power 9. So this will time out for sure, and also we'll also need to, for each day we'll also have to traverse the whole array to check if it is possible to make all the bouquet or not. So this is definitely not going to work. Then what's the next best approach that we can think of? So more efficient way here is to try an binary search approach. So what we will do is we will try to find the mid of these range. Like for example here, the mid of this range would be 1 plus 10 minus 1 divided by 2, that will be 4. So this will be 5. So what are we going to do? We are going to try out if it is possible to make all this bouquet in 5 days. So we will first try for 5 days. So now we will try and say that we'll traverse this array and check which are all these flowers are bloomed on day till day 5. So basically this one, and this is not bloomed, so we cannot make any. This is bloomed, but this is not bloomed, so we cannot make any bouquet till now. Again, then we can see that this is bloomed, but this is not bloomed, and so on here and here. So we can check by going through all this array sequentially and check if it is possible to make this 4 bouquet. And we can see that on day 5 only this and this flowers were bloomed, so we cannot make definitely on day 5. So when we found out that 5 is not possible, so any day before day 5 will also be not possible. So what we will do, we will try from 6 till 10 now. So the left should be increased to mid plus 1. So the left is, that means the minimum should be changed to 6 and maximum should be 10 now. So what's the next mid that we can find? The next mid would be 6 plus 10 minus 6 divided by 2, which will be 2. So next mid would be 8. And then we'll find out if it is possible to make all these 4 bouquet in 8 days. So on day 8, all of them will be bloomed except this one and this 9. So because these two are not bloomed, we will not be able to make till here and till here. So we can only make using this subarray. So using this subarray, we can at max make 3 bouquets. So we'll definitely say that hey, this is not possible to make this one within 8 days as well, and so there is no point in checking day 7 and day 6 as well. So we'll just move our left pointer or the minimum, the range for this minimum to next of 8, that will be 9 and 10. So this is the next range that we are going to find, and within 9 and 10 the minimum, the mid will be 9 plus 10 minus 1 by 2, which will be 0, so it will be 9 only. So we will check if it is possible to make within 9 days or not. So this will become open, so we can use this one as well to make the fourth bouquet, as here we could see that we were able to make 3 bouquet. So now we can make all the 4 bouquet, and this was the first time that we found this, and hence now what else we are going to do is, because we are sure that we found something where it was possible to make, then it can be possible that we can this, let's say if this mid was somewhere here, all right, so somewhere here means there can be a possibility that there are certain number of days before this where also it could be possible. So what else we need to do here is we need to then change our high to, or this maximum to this mid, that now that we know that we can make between this existing 9 and this mid, which also is 9. So now that we have seen that both our minimum and maximum value in the range of date has become equal, that is 9. So we can, this is the last range that we have to check, because there is no mid in this one. Will be forever in a loop if we'll keep trying to find the mid by the formula mid plus high minus low divided by 2. So this is the time when we also ensure that our answer has been found, and that answer will always be stored in the left of this left value. So whatever is stored in min would be our answer. So I hope I was able to explain you guys. Let me also walk you through the code. So this is the code. Let me just explain you what I've done here. I've just checked if it is impossible to make this all the bouquet, and as we discussed earlier that we can just check how many flowers we need to make all these M bouquet and the total size of the garden. If this is garden size is smaller than the total flowers that we need, then we'll say that it is impossible. Otherwise it is always possible to make. And here I have just taken out the minimum and maximum value as we discussed, and from our array, and then doing a binary search here. So while small, the MA is less than MA, what I'm doing is I'm just checking the mid value, which would be this, and then for this particular mid I am checking how many, this particular number of days I'm checking if it is possible to make all these M bouquet or not. So I am just traversing over this array and checking how many bouquet are we able to make. Here as you can see I am just keeping 2 variables, current and total adjacent flowers that we'll take. So whenever we see that one bloom day of I is greater than the amount of day that we have, the mid, that means this particular flower hasn't bloomed yet, then we'll simply change our reset our adjacent flowers to be 0, and otherwise we will increase our adjacent flower count. And if this adjacent flower count is equals to k, that means we have found a valid group which using which we can make one bouquet. So we will make one bouquet and increase this current count, and also we will again resize our adjacent to be 0 so that we can start counting for the next one. And if at any moment our current is equals to M, that means we have found a valid one. That means for this particular number of days we can form all the bouquet. So we can just break this loop, and then in the end we'll check if the total number of bouquets that were possible to make using these many days, if this is less than the total number of bouquet that we want, that means we'll need to increase our number of days. So we will check for the higher range, and so we will increase this low index to be mid plus 1 and the high index to be, Otherwise, yeah, high index here would be same. Otherwise, we have seen that we are able to make one particular bouquet. Consider this particular example, that if we, this is the else condition, that means we have seen that using these many days we can form all the bouquet that we want. So we will try to do a binary search within this range to find the minimum number of days. Alright, so I hope I was able to explain you guys, and if there is anything that you want to discuss or if there is any doubt, please let me know in the comment section below. And yeah, thanks for watching this video, guys.